Hey guys, today we're going to talk about a whole bunch of things, so we're going to jump into it because I know you want this video to go quickly. So here we go. First thing we're going to talk about is changes in state. Alright, changes in state. So, our states are that we basically deal with are solid, liquid, and gas. You need to know the terms for changing in state and how energy is applied to all of them. So, let's start with, let's say, a solid to liquid. Okay, when we go from a solid to a liquid, we call that melting. Alright, we call that melting. Next, what we have is liquid to solid. All right, when a liquid goes to a solid, we call that freezing. Next thing we have is going from a liquid to a gas. Liquid to a gas we call vaporization. Now, there are two forms of vaporization. Those two forms of vaporization are evaporation, which only occurs at the surface. That means when a liquid is going to a gas, it only occurs at the surface. And we have, boiling. Boiling occurs throughout. So when your water boils at home, if it's on a pot and it's boiling, the energy in there can boil from the top, the middle, the bottom. All that can go from a liquid to a gaseous state. Next thing what we have, is from a gas to a liquid. We call this condensation. So we call that condensation. This is what happens when you're sitting outside maybe on a really hot day, especially in Georgia, and you got a good old glass of like ice water or sweet tea for some of you maybe, and all of a sudden you'll see the outside of your glass gets really wet. Well, what's happening is the moisture in the atmosphere is coming onto your glass, and what it's doing is its energy is going in to your water trying to heat it up, which causes it to condense on the outside of your glass. So it makes it really wet on the outside. If you're from the South, you might have heard this term. People say that your glass is sweating, So we know glass can't sweat, but that's condensation. Now the last two changes in states we'll talk about, are a little bit fun. I really like these. These are going from a solid to a gas, A solid to a gas you've seen before. You saw it on Halloween, On Halloween we had dry ice. We had solid carbon dioxide. And it actually goes from a solid to a gas without becoming a liquid. We call that sublimation.
Yes, I have dry ice in my cooler here, and dry ice is CO2 in the solid form.
Solid form, right.
So let's just create, put that, some water here, and we're going to pour the water in here, and of course it is turning immediately into a gas.
And then the last one, what we have here, is going from a gas to a solid. Now of all of these, usually students haven't heard of this one, they call it deposition. Deposition is going from a gas to a solid. Alright, next thing we have to talk about are different types of reactions. There are two basic types of reactions or processes. The difference between it is Well, a reaction is going to be creating a new chemical, all right? So we're going to be taking those molecules and recombining them, all right? Whereas a process is there's not a new chemical created, all right? These are called endothermic and exothermic reactions or processes, all right? Endothermic sounds like in, and that's because energy comes in to the object, all right? The energy is coming in to the chemical, all right? So here's an endothermic reaction.
I brought some barium hydroxide octahydrate and some ammonium nitrate, and I'm going to combine them. Mix it around here. It's an unusual reaction in that it's two solids reacting with one another. Now, you don't see that very often. Hydroxide, very endothermic. So I've got this little block of wood here with some water on it. I'm going to show you how endothermic it is by putting this, that's all mixed up. It's a nice slurry now because all that water's been released. And I'm going to stick it on that block, and I'll come back to that in a moment. It's pretty cold by now. Not quite, it is there. So that block is, it's so cold that it froze the water that I sprayed onto the block.
Right? Next type of reaction is an exothermic reaction. That means energy is coming out. All right? Energy is coming out. So, here's an exothermic reaction. Oh, we're good. All right, we're about to do a thermite reaction. This is a highly exothermic reaction. So, here we go. What you just saw coming out of there, that red stream, that is molten iron coming down. That is molten iron coming down off of that. So really, really hot. This burns in the 2,000 to 3,000 degrees Celsius range. You can feel the heat from here. Can you feel it? All right, here's our molten iron. Here's what's left of our flower pot. Craziness. All right, next, what we need to do is understand the difference between three terms. All right, we have heat, we have kinetic energy, and we have temperature. All right, now, what is heat? Heat is the flow of energy, so heat's just a form of energy. All right, heat will always flow from a higher temperature object to a cooler temperature object, okay? So, it will always go from a high temperature to a lower temperature every single time. What does this mean? Well, it means this. If you ever take a glass of water and put some ice in there, right, here's what's really happening. Your ice is not cooling down your water. What's really happening is your water, right, is giving energy to the ice, so it's heating up the ice. Right? So the water's energy goes into the ice. Well, if the water is losing energy, that means it becomes colder. And that's how your drinks get colder, is because the energy is going from the liquid, the water, to the ice. Okay? That would be an exothermic process for the water, right? Because energy is going out, right? Causing it to get colder. All right, next, that's heat. Okay, so the flow. Next we have kinetic energy. Kinetic energy is energy in motion. And last we have temperature. Well, what's temperature? Temperature is the measure of average kinetic energy. So, all right, if you put them all together, all right, if I put heat into an object, okay, what's going to happen is the particles will move faster, so it raises their kinetic energy. So heat goes in, so energy goes up. And if kinetic energy goes up, well, temperature measures that. And so if kinetic energy goes up, then your temperature goes up. And there's your difference between heat, kinetic energy, and temperature.